Hello, everyone. Give me a moment for my slides to get set up and for any audio things to resolve. I'm going to keep talking until I get a thumbs up from up there. Great. Where are my slides? There. Excellent. Cool. Oops. No, it disappeared on me. There. Perfect. And like that. That should do it. Cool. And let me just tilt this over here so I can see it as well. Good morning, everyone. I see people here are morning people. This is actually kind of surprising. A lot of the conferences that I go to, it is a little bit empty at 9 a.m. and it starts filling in, so thank you all for being here super early. So today I want to walk you through the life cycle of what happens when we ship code into production. Because all of us here, we are technologists, right? We like to write code, but we like to write code in order to solve people's problems. And it turns out your job is not done with solving that person's problem until you actually ship it into production. Your job is not done when you just, say git commit, git push, it's out there, right? So let's talk a little bit about what that looks like when you ship that code to production and how we can make that process better for you and for your teammates. So our production environments are so complex. And the reason why they're so complex is that we are always adding new features. We are always adding new things that we aim to delight our customers with. And this is especially true when we need to adopt technologies like cloud native and big data in order to better serve our customers. Because those add a large amount of power, but a large amount of complexity. So we have to think about how do we manage that complexity? How do we make that easier for us to understand as operators of the system? And that complexity also takes the form of every time someone adds a pull request to your code, right? Anytime someone adds a new microservice, anytime someone adds a new widget to your single page app, right? We're always adding complexity. So we kind of have to take a step back and say, how do we make this sustainable? And I think we also need to look at what uptime means to us. Because in the old days, when I was a baby sysadmin, I'm not actually that tall, by the way, but when I was a baby sysadmin, we used to have this idea that your servers were either up or they were down, right? That if your server, you could ping it and you could access it on HTTP port 80, your service was up. Great, wonderful. And if your service was down, then every alarm would be screaming at you. Well, we don't operate in that world today. Our world today is not necessarily everything is binary up or down. And we should be a little bit more proactive. We can't say, I'm going to wait until I have customers calling my CEO on the phone and saying, I want to cancel my service, right? By then it's too late. Your company's probably going under. So we need to be a little bit more proactive than measuring things just by complaints. And then we also have to think about how do we find time between firefighting incidents, developing new features, how do we find time to work on the reliability of our services? And when we do find that time, how do we actually have the right strategies in order to move forward? So I know that this seems ironic coming from me as someone who works at a DevOps vendor, but I want to tell you, do not buy DevOps. No, really, do not buy DevOps. DevOps does not come in a package that you can go and hand over some money and buy from someone. When you wind up buying the alphabet soup, you actually get a completely counterproductive result. Because you wind up getting one of everything, even if it's not adapted to your needs. For example, let's say that you brought in a continuous integration and continuous delivery provider because you want to ship faster. That doesn't necessarily guarantee that the quality of what you're shipping is going up. That doesn't necessarily guarantee that what you're shipping is actually making your customers happy. Or what about infrastructure as code? You used to be able to take down one bare metal server with a single command. Now you can take down your entire Amazon Web Services environment with one single command. That's great, right? Well, maybe not so much. Or what's a Kubernetes, and why do I need one? I guess I want one. Everyone's talking about it. Let's get a Kubernetes, right? I'm not sure that's necessarily the best thing to do, right? We have to think about only adding the minimum amount of complexity that we need. But the number one thing that I see people doing that I worry about them a little bit is when they say, let's get PagerDuty, let's put all of our developers on call, without thinking about how do you prepare those developers to be on call. We talk often about the idea of production ownership, of teams writing software also being accountable for the running of it, but we do need to prepare people for it. Because otherwise, all of your alarms are going off all the time, and your engineers are getting so incredibly grumpy because they're up every single night with their pager going off in the middle of the night. They're not sleeping. They're not being creative when they come to work during the day. And eventually, they might just shut off the pager. They might just decide, you know what, this is not worth it. I'm not dealing with this. Or they might quit. And when you do find that engineer who's willing to spend the time looking into issues, if the first 30 minutes that they spend looking into an issue is looking at a wall of 20 different dashboards, each with 20 different graphs on them, then it's going to take a lot longer to figure out what's going on inside of your production environment. But unfortunately, this is what you get a lot of the time when you have a vendor come in and say, we're going to give you automatic dashboards for everything. Those aren't actually very useful, nor are the last 10 incident dashboards you created. Not very useful. And in the meanwhile, all of your customers are just sitting there and tapping their feet and being like, why is the site not up yet? Come on, I'm sick and tired of this. So we also have a problem where eventually that engineer says, you know what, I cannot figure it out. I'm going to wake up the senior engineer. I'm going to wake up the tech lead. So everyone's bugging the expert because all the knowledge is locked in their heads. And let's be honest here. How many of you are the expert in your company, at least for a small part of your system? How many of you are the expert that gets woken up? Yeah, right? It's a thing. We can be honest here. It's safe. We can be honest here, right? So we need to get out of that situation. We also need to make sure, as I was saying earlier, right, your continuous integration is verifying, does each piece work? We're not actually verifying, does the entire system work together as a whole? So we need to look at the broader picture. How are our systems actually functioning when we deploy them to production? So we're tired all the time. We have a lot of feature pressure. We're not actually getting the reliability work done. And even when you do have time, what am I supposed to do with this extra 2 hours that I have? How can I improve the reliability of my production system? So I'm really tired, right? The team's struggling to hold on. What do we need to do differently? I think what we need to do differently is, first of all, we need to take a deep breath. And then we need to look at who actually operates our systems, right? Our systems do not operate themselves. We, as human beings, are the people who are operating our systems. And that means that we need to make our systems much more reliable and much more friendly to our humans. And no, tools are not going to save you from this, right? A tool can help you do something that you intend to do, that your culture is oriented towards doing. It can nudge and remind you along the way. But it cannot reverse a pattern, right? If you have people who are shouting at each other, right, or blaming each other, no tool is going to solve that cultural problem. We need to make sure that we are adopting the right tools that align with what we are culturally doing and focus on making that cultural change. We need to make sure that we're investing in our people, our culture, and our process, rather than just investing in our tools. So this is what I call production excellence as opposed to production ownership. The idea that we need to make sure that our socio-technical systems are more resilient, that our systems need to be more reliable and friendly in order for us to sustainably operate them. And you do not get there by accident. You have to plan. You have to figure out what steps you're going to take along the way and how you're going to measure and get an understanding of, am I making progress? And we have to make sure that this is not just a set of people in this room, right? You have stakeholders that are outside of this room. You have stakeholders like your CEO. You have stakeholders like your customer success and customer support teams. You have sales teams, right? There are so many other teams that are not necessarily engineering teams that are involved in this effort of understanding what does it mean for our businesses to be successful. And we need to be able to communicate with each other. We need to make sure that people are asking questions, asking for clarification, and trying to get an understanding of how we achieve this together. So how do we get started? Today in this talk, I'm going to tell you the 4 things you need to do to achieve production excellence. The first one of which is you have to know when are your systems too broken, and only know that. Secondly, you need to be able to debug and figure out what's going on inside of your systems. And third, act in collaboration with other people to solve these problems. And then finally, we need to close that feedback loop. We need to eliminate unnecessary complexity in order to make sure that we are solving the issues in our systems rather than living the same outage over and over and over again. So why did I say telling whether the system is too broken? Why did I not say telling if the system is broken at all? Well, the answer is that our systems are always failing. That we no longer live in a world where the system is 100% up or 100% down. There's always some timeout in the system. There's always some small outage. You wouldn't want your entire lawn of grass to be entirely green. You just care that, does it look green enough? Can I go and play with my dog on the lawn, right? That's what you really care about. So that's what we care about with our systems. Are they working well enough or not? So that means we need a measure of what is working well enough, or conversely, what is too broken. So this is a concept from site reliability engineering called the service level indicator. The service level indicator enables us to tell what's going on inside of our services. And it's a common language between us and our business decision makers and our customers. It enables us to really measure what is a satisfactory level of service. In order to measure a service level indicator, we need to have an idea of what our critical customer journeys look like and what events in terms of telemetry that translates to inside of our systems. And what's the context of the request? For example, which users were affected? Where did they come from? What language were they speaking? Which version numbers did they hit inside of our system? Which microservices did they hit, right? So many different elements of context go into that critical user journey. And then we need to be able to tell, is that critical user journey a satisfactory customer experience, or is that an unhappy customer? One way of figuring this out is to ask your neighborhood product manager or a UX researcher, right? A lot of people wind up having exposure to what makes your customers happy or sad. Or if you're really, really not sure, you can do a chaos engineering experiment. You can say, what happens if I inflate the average latency of my service from 50 milliseconds to 300 milliseconds? Do people start complaining? That's a useful touch point for knowing what fast enough means to your customers. So speaking of fast enough, in addition to just not serving errors, we may want to know what is fast enough to our customers. What thresholds buckets an event into a good event or a bad event? So for instance, I might say I'm aiming to achieve an HTTP 200 on each transaction, and the latency needs to be less than 100 milliseconds. We then need to look at the broader picture of how many eligible events did I see. Not all the events in your system matter. Some of them are automated health checks, some of them are to non-critical endpoints, and some of them are botnet attacks. Why should I care about all of those, right? So we need to look only at the actual set of eligible real customer events. And then we can compute the availability number, the fraction of good events over eligible events. And that enables us to set a target, our service level objective. But there's one other element besides the proportion of availability that we need in order to set that target. How long am I measuring over? If I were 100% down yesterday, and I come to you and say, guess what, we're 100% up today, would you believe me? No, I don't think so, right? People have a longer memory than one day. So you typically want to measure your availability over a longer window, for instance, 30 days or 90 days. So a complete service level objective definition might look like 99.9% of events will be good over the trailing 30 days, where an event is good if it was served with an HTTP 200 and it was served in less than 100 milliseconds. That's a service level objective definition. So why should you pick not 100%, and why should you pick, say, 100 milliseconds? Well, a good service level objective should barely keep your customers happy. If you are aiming for 100%, you are throwing a lot of money on fire because you are giving up either money or product velocity in exchange for reliability that your users won't actually perceive. We want our users to experience just the smallest amount of unreliability that they're willing to tolerate, such that we can move and iterate as fast as we can. So what use is a service level objective? There are two purposes for a service level objective. The first one is that we can drive our alerting with service level objectives and turn off all the other useless, noisy alerts. In order to understand this, we need to think about the error budget. What's our allowed amount of unavailability? If I have a target of 99.9%, that means that 1 in 1,000 events are allowed to fail. So that means that if I am serving 100 million events per month, I can allow 100,000 to fail per month. So then I can figure out how long is it going to take me to run out at my current rate of errors. If I am serving 1,000 errors per minute, then I have 100 minutes. That means I need to wake someone up right now. If I'm serving 1,000 errors per hour, then I'm going to run out of my error budget in 100 hours. That's fine. That can wait until business hours. That can wait until the end of the weekend. That's okay. The second thing is that we can make data-driven business decisions. Do I want to move faster? Do I want to move slower? When is the right time to allocate more priority to reliability items on my backlog? Is it safe to do this risky experiment? Well, if I've got plenty of error budget left, and I have a feature flag system, then I can go ahead and opt people into this experiment knowing that I can roll it back and not impact my error budget too badly. Conversely, if I've had a set of really bad outages, this is my argument, right? This is my argument to say, you know what, product manager, we agreed we were targeting 99.9% reliability. We're in danger of not achieving that. We need to slow down and not deliver features, or else our customers will abandon us and no one will be there to see those features. You don't have to be perfect at developing a service level objective. It's far better to know what you don't know than to not know what's going on inside of your system. So measure what you can today, whether it be from your load balancer logs or from your applications logs, and then iterate over time. Maybe eventually one day you'll decide that you need to measure the experience from your mobile app, but that might not be today, and that's okay. Over time, though, what we can do is we can make our system adapt to user needs. If we have outages that are not being caught by our service level objective, that means that we need to adjust our service level objective. Conversely, if our SLO is firing, but our users are not complaining, maybe we can relax it. Maybe it's okay to have a little bit less reliability and more velocity. So when you only alert on what matters and turn off the disk is 90% full alerts, you can wind up getting a much better night's sleep. But that's only half the picture. You also need to be able to debug your systems. Our outages are never identical. Or if they are, you're living in Groundhog Day and you should probably stop doing that. So our outages are never identical. And that means that we need to have tools that work to debug outages that we've never seen before. You cannot predict every failure mode that would happen inside of your system. Or if you could, you'd probably be a lot richer if you bought lottery tickets instead. So we have to be able to debug novel cases of production failures in production. Your customers will not wait for you to reproduce your problems inside of a staging environment. Your customers will not wait for you to say, you know what, I'm going to leave this broken in production so I can have a look at it, right? We have to be able to get the telemetry we need from an outage and mitigate as soon as we can. And that means we have to be able to formulate hypotheses. What do we think is happening inside of our systems? What do we think has caused this outage to trigger, and how can I revert it as quickly as possible? That means that we have to be able to ask new questions of our data and not just the questions that we thought to allow when we initially created our programs. All this to say that our services have to be observable. Our services have to allow us, without pushing new code, to ask new questions of the services. Can we actually understand our events inside of our system in their full context and with all of their varying attributes? Can we explain the variance? What separates a slow event from a fast event? What separates an erroring trace from a normal trace? And can we roll back the bad release? Can we drain the bad availability zone and debug it later during business hours rather than waking someone up? Observability, though, is not just break fix. There's an entire life cycle that observability can help us with, ranging from, can we iterate quickly when we're debugging and understand what's going on in our code even as we're writing it? Can we get predictability in our release schedule? Can we understand, are we wasting effort, or are users actually using what we develop? And can we make the argument to fix technical debt? Observability is also not the data. Unfortunately, a lot of people claim observability is logs, metrics, and traces. It is not. It's the wider usability picture. Can we instrument our code in an ergonomic fashion as easy as adding a printf debug line? Can we query it in ways that make sense to us and get the insights that we need? So SLOs and observability go together, because SLOs let you know when things are too broken, and observability lets you be able to debug and figure out, how do I get things back to a state where they're broken about the right amount? But you also need to have collaboration between your teams. Collaboration enables you to succeed in an environment where you cannot individually be a hero. You cannot individually solve every problem inside of your services. A lot of us work with cloud providers, with other teams, and it's really, really important to make sure that we bridge those gaps. We don't debug problems solo anymore. If you're on call for not just your own code, but the code that your team wrote over the past year, and maybe previous teams wrote. We have to work together across organizational boundaries as well. We have to work with other software engineering teams. We have to work with customer support. We have to work with potentially people working in data centers, right? We have to be able to communicate in the same terms as other people. And that means that, maybe we need to do things like game days or disaster recovery drills to make sure that we're actually practicing in advance of real incidents what we expect to happen. We also have to make sure that people feel safe and comfortable talking to each other and relating to each other. And we have to fairly allocate responsibility between varying team members. It's not okay to put managers on call when they are giving performance reviews, right? It's not okay to make people with young children be on call when they're also getting woken up by their kids in the middle of the night. And we should make sure that people who have religious reasons for not being on call, for instance, Friday night into Saturday night, shouldn't be on call during those times. On call is a team sport. We can share the load evenly rather than saying everyone has to be on call for 7 days for 24 hours each day in a row. We also have to make sure that we're documenting things better and that we're developing this idea of having a playbook, right? Having a playbook not that is fully exhaustive and gets out of date, but instead, what do I do to put out the fire right now inside of my service? Or what's the overall diagram of all the services that we support? And that means sometimes, yes, you're going to have to go and call up that senior engineer and say, you know what? We really need to document this and get it written down because I don't want to have to call you about this in the middle of the night. And use the same platforms and tools, right? Use the same instrumentation frameworks, for instance, OpenTelemetry. Use the same documentation runbook sites. Use the same observability tools, right? It is not okay for teams to say, you know what, it looks green on my dashboard, right? That doesn't actually solve your problem. So let's make sure that we're using the same platforms and tooling and language together. We also have to make sure that we're rewarding people for curiosity and teamwork, right? Rather than saying, you know what, I can't believe you didn't know that, right? Instead, what if we said, thank you for asking that question. I'm glad that you asked that because we need to document more, right? That sounds completely different, right? It rewards a completely different culture. So make sure that you are saying, or like you have somewhere to record, whether it be peer bonuses, a Slack channel where people say positive things about each other, right? Make sure you are delivering those positive signals back to your team. We also have to make sure that we are learning from the past, that we're not repeating the same outage over and over and over again. So that means that we need to have a blameless culture, and we need to also be recording how we did in the past and how we can improve. Because our outages are not necessarily exactly the same, but you can definitely see some common patterns with our outages. So this means that we need to conduct risk analysis to plan and figure out what should we be doing differently? For instance, this morning, I walked across that lovely bridge that's right in front of the venue, and I thought to myself, you know what? If there were holes in the bridge and cars and bikes were falling through, and maybe sea levels are rising and eventually we should move the bridge, right? Which one of those two things do we want to address first? There's not actually a hole in the bridge, don't worry, but hypothetically, right? So this means that we have to think about how often do risks happen and how bad are they if they happen. So we often do not have control over how often things happen. You know that one MySQL database server is going to crash at some point in the next year. You don't know when. You probably don't have very much control over it, but you know it's going to happen, right? What you can control is how bad it's going to be for your service. How long is it going to take you to detect it? How long is it going to take you to repair? And what percentage of users are impacted? Because there's a huge difference between 100% of your users being taken down by a bad MySQL server and 1% of your users being taken down by it. So we need to multiply these numbers together and get the expected number of bad user queries generated by each risk over, say, a year or 30 days or 60 days. And then we can figure out which risks are the most significant, which ones are the most worth working on. And if you're not sure what your risks are, there's an entire discipline devoted to failure analysis. Whether it be systems theoretic process analysis or fault tree analysis, these are useful ways of figuring out what the failure points are of your system. So which risks should you actually address? Address the ones that threaten your ability to deliver according to your service level objective. If your service level objective says, I aim to have no more than 100,000 bad events per month, and you have one cause of failure that would cause 50,000 bad events per month, guess what? There's your business case, right? That is 50% of your error budget, and that leaves very little room for any other potential causes of failure, as well as for things that you haven't predicted yet. So make the business case to fix any kinds of failure modes that you think are high risk to your business. And actually prioritize completing the work. A lot of us, when we write postmortems that say, fix this, fix that, fix the other thing, right? Like we write these postmortems that have like 100 or 200 items in them. Don't do that, right? Focus on what are the top 3 things that I need to do in order to mitigate this risk. And don't even bother putting the things that are nice to have on your backlog. They'll never get done, right? Like they'll just make you feel bad. So prioritize doing the things that are actually high risk to your business. Do not waste your time doing things that are low impact. Do not waste your time polishing the chrome on your car, as it were. But in closing, I want to say that lack of observability is a systematic risk. If you do not have observability, that means that every outage that you have is going to take 20, 30, 40 minutes longer, or maybe even hours longer while you're trying to figure out what's going on inside of my system and how do I make it stop hurting. So really, really invest in that capability to understand deeply what's happening inside of your system. The second risk that I want to talk about that many people don't write down in their risk analyses is lack of collaboration. If you have a customer support team that gets yelled at every time they call the engineering team on the phone and say, hey, I think there's a problem, when that big outage hits, you'll wind up in the dark for 20 or 30 minutes because no one will feel like they can safely raise it to you. So make sure that people are communicating well in advance of any large outages. You don't have to be a hero to have a successful team. You don't have to say, we all have to be heroes to have production ownership. Instead, we need production excellence. And to get there, yes, some tools can help you along the way, but really, you need to invest in building the right culture. So buy the alphabet soup, but season it with some production excellence practices. So in summary, production excellence helps you run a more resilient service. And in order to do it, you have to measure when things are too broken, be able to debug, collaborate with other people, and fix the long-term issues. Thank you very much.